our founder and CTO, I'm sorry, Paul Dix. He's going to have a really interesting talk like always, but he really enjoys fielding questions from all of you guys. So I want to make sure that everyone starts to populate the Slido app with your questions, and let's make them hard. Let's see if we can challenge Paul a little bit. So before I hand it off, last moment for you guys to put in the Slack channel what color hair you think he has. And when I hand it over, you'll get the surprise of what the color actually is. So without any further ado, I'd like to introduce to you Paul Dix.
All right, thanks, Chris. So I am sorry to disappoint everybody. My hair is just its natural dark brown, graying color right now. This is actually going to change soon. I have to dye it on Thursday evening. I'm going to be bleaching it for an outfit for Halloween. So, and then who knows, maybe then I can go with an actual color on next week. But so yeah, thank you so much for coming to InfluxDays and for coming to my talk. Today, I was actually going to do something a little bit different than I normally do for InfluxDays. Normally, my talk is fairly in-depth technically and about a bunch of future stuff. Today, I was actually going to talk a little bit about why we're doing time series and why we're doing InfluxDB, highlight a couple of customer stories, one of which actually Evan already touched on, and then talk a little bit about how we break up the problem of working with time series data and some of the work that we've been doing recently and will be doing over the next year and the developer experience we're driving towards. So, hold on. Question for the moderator. Can you switch over to the presenter view really quick? Thanks. Thank you. All right. So this is the core thesis. Basically, if you want to observe anything about the world, any sort of data in the virtual or physical world, you're collecting timestamp data. And furthermore, if you want to analyze and learn from that data, you're actually working with time series. You're breaking up all this data into time series. Usually you're adding some sort of structure to it so that you can get intelligence from it. The truth is, we believe that all data is based in time. No matter what data it is you're collecting, there is a time component to it. Even if you think about a reference database, like a relational database that stores a customer list or whatever, it represents the state of the world at some point in time. Usually that point is now, but time is there. And the broader trends, and Evan touched on this as well, is that we think that everything that can be instrumented will be instrumented. This is cell phones, this is sensors in agriculture, in factories, in power generation, in cars, literally everywhere. But what all that instrumentation will lead to is that it means everything that can be optimized will be optimized. Think about better energy efficiency or water use or any of these other things. Small optimizations will actually yield good results when deployed at scale around the world. So for our part, we've seen a couple of use cases that I want to highlight in our customer and user base that I think are worth talking about. So the first is this company, Bbox. They're out of the UK. They've actually been a customer of ours since 2015 or 2016, so quite some time. So they develop and manufacture products to provide affordable, clean solar energy to off-grid communities in the developing world. So their name is short for Battery Box, and their whole system consists of a solar panel, a battery, and a set of USB and DC connectors to power lights, radios, and low-powered televisions. The unit also includes a set of electronics to allow Bbox to control it remotely. Now, they use InfluxDB to store and work with all of the telemetry data coming off of these units deployed out there in the world. Now, the stats you see there on the slide are actually a little bit out of date. If you go to their website now, they say they have over 2 million people getting power from Bbox systems, from solar power. By their estimates, they've helped avoid 640,000 metric tons of CO2 and replace more than 1.7 million kerosene lamps. So that's real change that they're driving out there in the world. Obviously, we are not developing solar power, but the thing we are trying to do is develop software tools that make it easy for people who are solving those problems to do it with less code, less configuration, and in less time. Aquacore is another interesting one. So they're an IoT smart asset operations platform for commercial real estate. So they offer a cloud-based platform to track, analyze, and predict building and energy data in real time. Now, they chose InfluxDB Cloud as the managed time series database to collect and store metrics and event data from utility meters, submeters, building equipment, and environmental conditions of the buildings, all of this so that they could get energy reduction footprints and stuff like that. As you can see from their stat, 30% savings in reducing monthly utility bills, which means less carbon burned, which is great. In South America, we have the Vera Rubin Observatory. So what this project does is it will be using the Rubin Observatory LSST camera and the Simony Survey Telescope. I'm not sure if I pronounced that properly. Their mission is to build a well-understood system that provides a vast astronomical data set for unprecedented discovery of the deep and dynamic universe. The project's goal is to conduct a 10-year survey of the sky that will deliver a 500 petabyte set of images and data products that will address some of the most pressing questions about the structure and evolution of the universe and objects in it. So they deployed InfluxDB, the platform, and it's helped them better understand their telescope, camera, observatory, and data. The space ones are always pretty cool, I think. So yet another space one. Loft Orbital flies and operates customer payloads in its microsatellites as a service. So they use Telegraph, InfluxDB, and Google Cloud to collect and store telemetry data from their equipment. This includes spacecraft on orbit, and additionally, they're monitoring the infrastructure supporting their missions, including servers and containers. Now, Evan mentioned InFarm in his talk, vertical farming company that uses Influx. There are a bunch of others that are doing vertical farming, trying to get improved water use, clean energy, and all sorts of things. We find those really, really interesting, those use cases, in addition to all of the obvious like server monitoring and observability stuff we help with day to day. Now, what innovation has driven this like change over the last 10, 20 years? Usually when you see stuff like this, there's some sort of enabling technologies that made it possible. And really, we think it comes down to three key things. So the first is wireless speeds improved and the coverage has gotten significantly greater. For example, 20 years ago, Bbox couldn't have existed because you wouldn't have had wireless coverage in the remote areas that they're deploying off-grid energy. So the other thing that happened is sensors have become cheap and ubiquitous. They can be deployed at scale all over the world to gather this kind of data. And finally, you have compute power at the edge that's getting smaller and, again, less expensive to deploy. Now, all of this hardware and network innovation requires enabling software to work with it at scale and deployed all over the world. InfluxDB is our solution to that. It's our enabling technology for time series applications that operate at the edge, in the cloud, and everywhere in between. That way you can quickly build analysis, intelligence, and automation from all of these newly available data about the world. Really, we think time series are not only historical observations, but they're also predictions of the future. So if you're building a system that has to predict the future or be intelligent or take automatic action, it's likely that time series is going to be the common abstraction that you use to look at that data. Whether that data is metrics data, like you see in a dashboard here, or it's financial market data, or user analytics, or even raw log data that you structure later. All of this coming from your servers or sensors deployed in the real world or in virtual worlds. So when we talk about time series, we talk about two different kinds of time series. The first of which is probably what people think of most when they think about time series is regular time series. So these are samples collected at fixed intervals of time. Think once a second, or 1,000 times a second, or once a minute, or once an hour, or once a day. These regular time series are usually summarizations of some other underlying distribution or some raw event stream. So a raw event stream is an irregular time series. These are just individual events on a timeline that you collect as they come in. These could be a ship coming into port, a machine turning on or off, a request to an API. Now, the interesting thing about irregular time series is that you can actually create a regular time series from an irregular one on the fly. So take, for example, we just want to get the count of individual events for each of these time windows between T0 and T1, T1 and T2, T2 and T3. So there we can see the computed counts. So we've taken an irregular time series and converted it to a regular one. The long-term goal for InfluxDB is that it will be the home for all kinds of time series data, whether it be metrics or events or any of this kind of stuff. Now, when we think about solving problems in the time series space, we think about 4 common areas of functionality. These things we think we can build common abstractions around that make it easier for developers to create applications. So the first is to collect and transform the data, right? You have to collect it from whatever source. You potentially have to run some computation on it and transform it so that it can then be ingested into InfluxDB. So you can store and query that data so that you can perform analysis and do, see it basically. And then lastly, you want to process, monitor, and alert and act on that data. Once you've actually done some analysis on it, you want to be able to process that data either in real time as it arrives or periodically in batch. So you can do monitoring, alerting, and trigger action. And to tie all of this together, you need the platform to help you manage and secure the data so you can operate your application effectively. So the 3 user experiences we think about when we think about creating a time series application. So the first is the obvious developer experience, right? We have the command line interface, the API, and then the client libraries in whatever language you happen to be writing your application in. Then we have the user interface. We want people to be able to log into our UI and be able to do all the things they need to do if they just want the UI experience. But recently, we actually started development on a Visual Studio Code extension. This initially started as basically an extension for the Flux language, and it's expanded beyond that. And I have some examples later in the talk. But our goal there basically is, as a developer, if you're in VS Code, you'll be able to do everything you need to do within the IDE and not have to exit out. You could not touch our UI at all and basically just do everything from VS Code. So the functional areas we can get back to. I'm going to talk about a specific example in each one of these. There's a lot more to each of these, but I wanted to kind of narrow the scope of what I'm talking about today. So the first is collect, right? When you collect the data, you want to transform it. You potentially want to monitor at the edge, and then you want to feed it into the place where you're storing it. Now, traditionally, this is what InfluxDB users have thought of the collect stage as. You have Telegraph, which can collect system metrics. It can collect data from a variety of third-party sources and services and do calculations on it or transformations on it, and then feed it into InfluxDB so that you can work with it. But more recently, this is kind of how we've been thinking of framing the collection problem. You have the serialization format, you have the messaging system, and then you have the transform step. So on each one of these, we want to enable greater integrations so that you have more options for what to use. So on the serialization format side, we have JSON. These are the formats we're thinking of initially, but obviously we're going to expand this over time. But you have JSON, protobuf, CSV, line protocol, Parquet, and our own time series merge tree file format. Now, the thing about JSON and protobuf there are a million ways to represent data in those, a million different schemas that you could have. So that's where the transform step becomes important. But before we get there, we have to put all this data into a messaging system so that we can ingest it asynchronously. So the initial ones we're looking at, MQTT, which will actually launch into our cloud product soon, where you can hook our cloud up to your MQTT broker, and it will ingest the data without you having to do anything else beyond piping it into the broker. Kafka, which I'll talk about a little bit later, Kinesis, Azure Event Hub, and GCP PubSub. Our goal is to provide, broad support for open source messaging systems, as well as the messaging systems within the cloud providers, the first class ones. And then the last bit is to transform that data into a format that's usable by InfluxDB. Today, you can do that using Flux. Flux is, again, not only a query language, but a fully functional scripting language. But we also want to add support for Python and JavaScript and TypeScript. We chose those two languages mainly because of their ubiquity and the large audience sizes we'll be able to touch with those choices. All right, the store step. Now, when we talk about storing data, we want to be able to work with it in a distributed way, but we also want to work with it in a federated fashion. So we're integrating data at the edge and in the cloud. And we want a variety of ways to query that data. So from the query side, obviously today we support Flux and InfluxQL. And then coming next year, we're going to have first-class support for SQL for the first time ever. So this is going to be a Postgres flavor of SQL. So underlying these improvements is the project that I mentioned before, InfluxDB IOX. So InfluxDB IOX is the new open source core of InfluxDB, and it's enabling all sorts of new and interesting things. The first thing to mention about IOX that I think is important is that we're doing all of the development out in the open. It's MIT and Apache 2 licensed, dual license, like pick whichever one works for you, right? And the key thing is it's just that license. It's not like some sort of community thing. There's no limitations on it. You have absolute freedom to do what you would like with the code. We ask that you give feedback, but again, not even that's required. Our goal is to release something out there into the world that people can use broadly, regardless of their use case or whether or not they intend to build a business on it. Our intention is to build a cloud service, which is how we're launching it first, that uses this open source software and becomes the best place, the easiest place to run it. Now, I want to mention that InfluxDB IOX is written in Rust. For some of you, that may not matter, but I've been very excited about Rust as a programming language for a number of years now. And I think it's actually a perfect choice for this kind of software. And I think it gives IOX a very solid foundation to build a multi-decade project off of. So within that, we're using the Apache Arrow project. So Apache Arrow is an in-memory columnar data format or columnar data specification. And we use that in a number of places for data interchange between servers, but also within memory. We use some other pieces of the Apache Arrow project. So specifically in Rust, there's a project called Apache Arrow Data Fusion. What that is it's a SQL planner and executor that gives us that native SQL functionality. So we're contributing heavily back to that. And that's a project that's being developed under the Apache Arrow banner, right? So there are a number of other companies that are contributing to that code, which is exciting for us because it's the first time we've really had a core part of our platform that was being written by multiple companies at the same time. It really takes advantage of one of the strengths of open source, which is the ability to collaborate with people across the world in different job functions. And then lastly is Apache Parquet. So Parquet is a persistence format for columnar data. It's highly compressed, and it allows us to have a smaller footprint than even our previous storage engine did for our kind of data. Actually, there was one other bullet I meant to include on here that I forgot, which is lastly Apache Arrow Flight. So Arrow Flight is an RPC mechanism and specification for high-speed data transfer of columnar data between processes and servers and stuff like that. What that means is if you want to connect to IOX for any library, any language that supports Apache Aeroflight, which is a good number of them, Java, C++, Rust, Go, JavaScript, PHP, Ruby, all of those. It's literally a couple of lines of code to connect to IOX and to execute a query and get results back super, super fast. So this is the headline feature that IOX brings to the table. Unlimited cardinality. We want you to be able to write data in without having to worry about how many unique values you have in your tags or anything like that. But the other interesting thing is that we're using object storage as the durability layer. So what that means is we've decoupled the compute side of the equation from the storage side of the equation. That also affords us other interesting architectures, like potentially being able to separate ingest from query workloads from, say, compactions that compress the data in better formats, right? So it will also enable us to deploy on the fly additional query capacity by just pointing at object storage and pointing it at our write buffer. Bulk import and export is something that we're enabling outside of IOX, but IOX will also open up, I think, some interesting possibilities for doing bulk import and export. Specifically, we'll have client-side tooling. They'll help you convert your data from whatever format it is into the Apache Arrow Parquet format so that you can just load these large blocks of compressed data right up to S3 and tell IOX about it. Which means that you can potentially ingest, way more data than you ever previously could in a shorter amount of time than when you had to write line protocol line by line to the database. And then the last bit that I'm excited about is an embedded JavaScript and TypeScript engine. So this will be based on a project in Rust called Dino. Which is an interesting project and company, but they have basically the V8 engine wrapped in Rust. So it has all these native Rust bindings for executing JavaScript within the system. I think the reason why I think that's interesting is because it will allow IOX to operate at the edge in arbitrary contexts for doing ETL, for doing collection, for doing transformation, for doing monitoring and alerting. So you can push all of that stuff down to edge nodes if you want. So this is just a quick look at what the architecture looks like for how we've deployed IOX into our cloud products. So this is basically as much of a technical deep dive as we get in this talk. But at the top, you have the IOX routing layer. So this is IOX as a server can operate in a few different modes. One of those modes is as a routing layer. So its only responsibility there is to accept write requests in the V2 write API and convert that line protocol into a binary format that gets put into Apache Kafka. Then on the other side of that, we have query servers reading from Kafka. Now, the structure of the Kafka setup is that we have one topic per bucket, right? So basically, we can get a level of isolation across different buckets and across different tenants. So we can have dedicated query servers for larger tenants, or for a bunch of small tenants, we can have them multiplexed onto a single query server. But this structure makes it so that we can trivially add new query servers to the mix to spin up query capacity. They can read from the Kafka setup and they can read from object storage to get all of the data. And it also enables those things, like I said, like pushing compactions off to systems outside of the actual query processing pipeline. We could potentially also see cases where we have query processing for interactive like dashboard queries, and then query processing for monitoring and alerting style queries, and have those actually separated onto different instances. It just gives you better like fault isolation in case something goes wrong, and it gives you the ability to scale those things independently when it's useful when you start operating at much more significant scale. So then the other thing about the routing layer is that queries will come into it and they will get routed to the appropriate IOX server based on which bucket it's hitting and based on, load and stuff like that. So the other piece, as I mentioned, is this vision of having InfluxDB at the edge. So initially, this is going to be actual InfluxDB open source in a future release, but IOX is also going to be optimized to work in this fashion. So you can imagine a number of InfluxDB instances operating at the edge and seamlessly integrated with the cloud product or with a centralized InfluxDB setup. All right, let's talk about processing really quick. So processing is like it's a generic term, but really what I mean by that is the data is arriving, you need to do something to it, right? You need to check the values of the data and compare it to other values so that you can trigger an alert or trigger action. You need to transform that data or do data enrichment. It's just kind of a generic catch-all. But the thing that makes processing like an interesting challenge in time series is that you pretty much have to process all of your data potentially multiple times as it arrives for all of these individual conditions that you might want to be looking for, right? Usually in like a reference database or something like that, you're not really doing that. And you're certainly not doing that at the same kind of scale. You're not writing billions of new records into your customer database every day. Or if you are, congratulations. Things are going very well for you. So jumping back to that collection diagram that I had earlier, this transform piece can also be thought of as a processing piece, right? Transforming is just a specific instance of transforming the data. But potentially you could monitor it at the edge, you could alert and act at the edge, in addition to sending the raw data up to another server or downsampling the data and writing, lower precision data up to the other server. And just like in the collection piece, we want to be able to support multiple options for how you process that data. Right now, Flux is the choice, but soon Python, JavaScript, and TypeScript. So you'll have a bunch of different choices for how you process that data, and you'll be able to express a lot with it. And this is what the part that I think is so interesting about this edge case is not necessarily just like replicating the data up to the cloud, because I think that's kind of boring, but really it's pushing processing down to the edge. There are a number of things in time series that are kind of difficult if you try to centralize everything, right? Things like computing state changes and keeping all sorts of stuff in memory and trying to figure all that out. Like if you have compute power at the edge and it's operating at a smaller scale, it'd be good to take advantage of that and actually push down what you can, and then ideally have the cloud system help manage all of that for you, so you can manage what's getting deployed to the edge, how it's running, when, checking on the health of it, and all that other stuff. It's all those additional bits that kind of make the collection and process stuff complex, right? And because of that, there's quite a bit of overlap in this collect, store, and process area, right? But at that kind of scale, the sensors that we'll be operating at, having everything centralized just doesn't really make sense. The future is going to be distributed, federated, and completely global. All right, last bit. You need to manage all of this complexity and all of this stuff. You need to secure your data, have an audit log. You need to be able to inspect what you're building as you're building it. One obvious thing is basically usage tracking. You want to see how much you're actually using. Our cloud product is obviously a usage-based product. So you pay only for what you use, but that means you need controls to see what's happening there. And we're going to be improving that over the next year as well. So the pieces of manage, you want to set security policies. We're going to be improving the level of granularity you have for setting fine-grained security controls over who can access what data and when. Usage policies. You want to be able to set limits on how much data certain tokens or certain users can feed in, they can query, and you want to be able to see who's doing what. Managing the deployment of tasks, I think, is an area that we can focus on quite a bit more. Tasks are code, right? So if you're going to write code, you need to have a methodology and a pipeline for how you deploy that code into production. and how that's managed. And that's not only tasks that are running in cloud, but tasks that are then pushed down to the edge, and you need to be able to manage all of that. And then there's audit logging for all of this, so you can see who's done what and when. So this last bit is actually a feature that we recently launched, which is basically schema locking and enforcement. So you can have a fixed schema, which is a long-standing feature request. This is actually just a screen cap of the documentation website. So if you look up Influx bucket schema, you'll find all the documentation for how to create a bucket where you can actually specify the schema up front, make updates to it, and basically reject any writes that don't match the schema that you've set. All right, last bit is on developer experience. So I'm just going to focus in on one area, which is something that's fairly new for us, right? This area, the client libraries, that's what a lot of people think about when they think about the developer experience. What does the API look like? What does the command line interface look like? And what the client libraries in the language that I'm writing my app in look like? These are the client libraries we have listed in our cloud product right now. We're obviously going to be adding to this over time. There are other open source options in each of these languages and in other languages that we don't yet have an official library for. But I think the really cool development that we've had over the last year is the development of this VS Code extension for Flux. Like I said, initially it was for Flux, but then expanded to be more of integrating with InfluxDB as a whole. So here's a screenshot of what that looks like. So on the left, you have the basic information about an organization, tasks and stuff. In the middle, I have a basic Flux script. And on the right, I have some query results. Let's zoom in here to the left. So there you can see I have my organization, Paul Co., and I can actually create multiple connections to different organizations within this view. And then beneath that, I can see what buckets I have defined. So the monitoring and the task buckets are obviously built in. Paul's bucket is one I created, and I just started writing some telegraph data into this. So you can see the CPU, disk IO mem, all the stuff that you expect from telegraph. So this just populates automatically. I have this pointed at our cloud product, an account I have there, but you can also point this at the open source. It works just as well. Then obviously in the center, you have a Flux script. So we have, command completion, syntax highlighting, all that kind of stuff. And there on the right, what you can see is I've actually executed that Flux script from here in VS Code, and I can see a result set. So that enables me to kind of fiddle around with whatever script I'm playing with and see intermediate result sets as I'm going, which I think is kind of interesting. And then the last bit is you can define tasks. You can add a task from VS Code. So here's what that screen looks like. I'm adding a task. I give it a name. I tell it how often I want this task to execute, and it actually creates that on the back end for me. So the other piece of all of this is basically this idea of GitOps flows. If you're writing tasks, if you're writing queries that get referenced in dashboards or basically fixed assets, things that people want to see, you probably want all of that stuff checked into source control, and you want to have a way to graduate it from development to staging to production. So you can do a lot of this stuff kind of manually right now, and we have documentation on the doc site to show you how to hook up some of these things. But I think we can streamline this over time and optimize it so that we have an ideal workflow that helps you, the developer, build a time series application initially, and then also iterate on it over time, defining tasks and all that other stuff. So just to recap, some of the things I'm excited about next year, we're going to be doing obviously a whole lot more than this. I'm probably leaving a million projects out, but just a few things from my talk. InfluxDB IOX, the new core of the database, which will have SQL support and unlimited cardinality. Ingest from messaging systems is going to be a first-class citizen. The initial one we're going to launch with is MQTT. Obviously, as I showed from my IOX slide, it has support to ingest from Kafka. more InfluxDB at the edge. Look for us to add more integrations to operate InfluxDB at the edge and work with it from the cloud product. Tasks in Python and JavaScript. Bulk import and export. And of course, more improvements on the developer tooling front. So that is all I have for you today. And I think I have some good time left over for Q&A. Okay. I guess I will just take the top question. So I'll read it aloud and we'll go from there. That sounds good. I'm just also going to open up Slack really quick in case somebody's trying to ping me. Okay, perhaps a slightly provocative question. What's your attitude towards InfluxDB users who have made an informed and intentional choice to stick to InfluxQL instead of Flux? Is the future of Influx 1.7, 1.8 secure for the years to come? So InfluxDB 2.0 supports InfluxQL natively. It's built in. So you can upgrade to 2.0 or you can use our cloud product. InfluxQL is supported there and we will continue to support it for years. There are some things that are really, really easy to express in InfluxQL that are harder to express in Flux. Just take more lines of code and stuff like that. But okay. So then one other question, sorry. When will InfluxDB IOX be available as a usable open source project? And when is it available in the InfluxData cloud? So IOX is an open source. We're hoping to put out official builds and documentation early next year. And then available in InfluxData Cloud, look for early next year. Basically, we're probably going to be doing both around the same time. But it depends. We're still kind of like fine-tuning what we want our rollout strategy to be. Right now, we're focused on mirroring production workloads on it. So we can do, verify correctness, verify, robustness and durability and all that other stuff. With all these things, I've said before a million times, when it comes to delivery estimates of software, there are lies, damn lies, and delivery estimates. Never trust an engineer who gives you a date, particularly if that date is more than, say, 6 months in the future. But we will try and get it out there as quickly as we can. The thing we won't do is we won't be putting out official open source builds until it's stable enough that we feel like other people should really start looking into it. If you're comfortable digging into the code and looking at issues, like I said, it's up there now today, and we definitely appreciate the feedback and the extra set of eyes. But as far as users go, we're still a little bit of ways away. It's going to be next year. Can you talk a little bit more about the MQTT broker you mentioned? How will this work? Is this with the open source version? Tim is actually going to cover the MQTT stuff a little bit in his talk coming up next. I believe the MQTT integration we have happening is in our cloud product, although there are ways to integrate open source with MQTT today by using the Telegraph plugin that will ingest from MQTT. So this is really more about having something that's kind of like fully end-to-end within our cloud product that people can use without having to install Telegraph as users of our cloud. Okay. Is the new VS Code experience for developers available for enterprise deployments or just the cloud product? So the VS Code experience integrates with the 2.0 API. So that's InfluxDB 2.0 or the cloud product. Now, the Flux side, the query side of things, the Flux query side of things will work against enterprise because that API is the same, but tasks aren't something that exist in enterprise, for example. But I believe the Flux stuff should just work. I'll have to look at that though. Yeah. Next question, what does the SQL support look like? Will I be able to write the same kinds of queries that I write with InfluxQL or Flux in SQL? I mean, it'll look like SQL, so there's that. So across InfluxQL, Flux, and SQL, there are varying levels of functionality. So Flux is basically what I call a superset of all of those, because there are things you can express in Flux that you literally can't express in InfluxQL or SQL because it is a scripting language. So for example, you can connect to third-party services to pull in data or to send data out. Like you can send something to PagerDuty or whatever in Flux. You just can't do that in SQL. But to express a declarative query, you will be able to do that in SQL as well as in InfluxQL and Flux. There's still quite a bit that we're going to need to do on the SQL side of things, I think, to make it a little bit easier to use. If you look at some of the basic like time series aggregation queries, like what is like a very short, easy to understand thing in InfluxQL ends up being this like super gnarly one-page SQL query with like windowing and partitioning. So I believe that we're going to have to add some functions in that just make it a little bit easier to use SQL in some contexts. How has using Parquet files on Object Store worked? So far, great. Like I said, the compression that we get on that is actually better than TSM, particularly for high cardinality use cases because of how the data is shaped. We have a lot more testing and validation to do, but so far it seems to be working pretty well. Like, I'm happy with the choice at this point. Yeah, and I think it's really advantageous for being able to hook into a broader ecosystem of tooling. Because if we just like have an API in IOX that says, hey, give me the Parquet file for this block of time, for this measurement or whatever, then you'd be able to work with that in any of a number of data warehouses or big data systems or client-side tooling that you have on your laptop. Dumb newbie question. There are no dumb newbie questions. There's just newbie questions. What is InfluxDB currently written in, and how will the Rust core impact compatibility with existing deployments? So InfluxDB is written in Go, has been since 2013. Basically, the new core is just the core of the database. So like the tasks system and a bunch of the other metadata and like the users and all that stuff that gets defined, that's really part of InfluxDB 2 or our cloud product. So within our cloud product, IOX is initially just replacing our core storage service that we run. Our cloud product is actually a collection of a number of services that provide all the functionality that the API exposes. So what we will likely do is have that same kind of thing with InfluxDB 2.x, some future release of 2.x that has that basically can use IOX as the storage backend. And we've already worked a little bit on building migration tooling to convert TSM data over to essentially the Parquet format that IOX expects, because we have to do that anyway to perform seamless migrations for our cloud customers so that we're able to switch them over to IOX with zero downtime, zero service interruption, and no migration that they can see on their side. Will IOX work with InfluxDB OSS? Does it support InfluxQL and Flux? Yes, the plan is that it will use the same communications protocols that we're using within our cloud environment. Those will get backported into the open source InfluxDB so that you can use IOX as the storage backend. SQL means there will be some sort of relational feature, i.e. join with a no time table. So right now within the core of IOX, time is kind of a special column that's expected to be there. Long term, I would like to be able to have tables that don't necessarily have time, but for the foreseeable future, time will be required. However, that being said, you can join on any criteria you want. You don't have to join based on time. So if you look, Data Fusion is really the project to look at if you're curious about what SQL functionality is supported, because all of the SQL functionality that we have is in Data Fusion. And like I said, we're heavily contributing to that, but it does things like joins and sorts and all sorts of stuff. It isn't obviously like it isn't the entire breadth of SQL because that's a massive amount of functionality, but it is gaining new functions and new capabilities week by week, and we continuously update to the latest version. So yeah, that's actually one of the exciting things about the project and the choice to use that. Why did you choose Apache Arrow? We chose Apache Arrow because we think it's essentially the lingua franca for OLAP systems and big data systems in the future, right? It specifies a persistence format and RPC mechanism for high-speed data transfer. The in-memory format is useful for us for transferring data within, like, from process to process or from partition to partition, like these various pieces internally. But if you look at data warehouses and big data systems, they already have or are starting to implement support for the Arrow like standards. So for us, it seemed like a great way to, pick a standard that a bunch of other people were supporting, so we get the maximum amount of integration with other third-party systems. Okay, let's see. InfluxDB has some data of metrics like CPU, memory, etc. Do you think add systemd database into InfluxDB for dbus monitoring system? Sadly, I do not know how to answer this question. This is going to be something for the Telegraph team, I assume. So hopefully in the Slack, they can provide an answer to that one. When you talk about processing with InfluxDB at the edge, when do you do the processing with Telegraph versus with InfluxDB at the edge? So Telegraph obviously doesn't have a storage engine in it. So it has no ability to do store and forward. You can't query it, right? If you need query capabilities at the edge, you're going to need InfluxDB, right? If you don't, then Telegraph is going to be a much lighter weight solution for doing your collection and sending the data through. But again, store and forward, query capabilities, that kind of stuff is going to be limited to actually having InfluxDB running. Let's see. Is there any strategy to change the time of data ingested later after consumption? This is a ridiculously hard problem to solve. Basically because the time is part of the primary key and you're essentially changing the primary key. So you're basically you'd be deleting a record and inserting a new record, right? Is essentially what you'd have to do in the traditional database sense. I am curious how you're changing the time of data. I also wish I could rewrite history from time to time, but I am curious about that use case. Let's see. Is there a beta program for the SQL support within our cloud environment? The best thing to do would be to reach out to, I guess if you're a customer, you can reach out to support. Our product management team, Balaji, is in the Slack. Also, you can probably find Tim Hall. I'm just going to point you at them. So yeah, definitely reach out because we would love to find people who are interested in beta testing it when it's available. And I believe I'm out of time. Maybe. Oh wait, hold on. I'm muted. All right. Do I have more time? Okay. All right. Well, thank you, everyone. Stay on for Tim Hall's talk. He's going to cover a bit more in depth about some of the recent stuff that we've been launching, particularly the MQTT, the fixed schemas, and function or scripted. I can't remember the name of the thing. Scripted functions, something like that. I got it wrong. I can tell Tim is shaking his head. So, all right. Thank you.
Cool. Thank you so much. There were a few other questions that we weren't able to get through in Paul's talks, but what we'll do is we'll post those questions in the Slack channel with the answers. But essentially, a number of them that were left were kind of similar, talking a little bit about the ability to test out the IOX capabilities, as well as the SQL capabilities a little bit earlier. And so we'll see if we can also have Tim cover that in his session. But thank you so much, Paul. Like always, it's super informative. And I think a lot of people gave you some thumbs up on the VS Code work. So people are pretty excited about it.